In this video, I'm going to discuss the first problem of 2026 USA Junior Mathematical Olympiad. It is an algebra problem with a flavor of number theory. Let a, b, c be distinct positive integers such that ab plus c equals c squared. Prove that a minus b squared is greater than or equal to 4c. The positions for A and B are symmetric. We want to compare them with C. First of all, one of them has to be greater than C. Otherwise, if they are both less than C, then they are less than or equal to C minus 1 because they are all integers. Moreover, as A and B are distinct, one of them is actually less than or equal to c minus 2. Then c squared, by the condition, is equal to ab plus c, which is less than or equal to c minus 1 times c minus 2 plus c. Simplify the terms, we got c squared minus 2c plus 2, which has to be less than c squared, because c as a positive integer is greater than another two distinct integers. So c is at least 3. Therefore, negative 2c plus 2 must be a negative number. Now we have c squared is strictly less than c squared. That is a contradiction. Without loss of generality, we assume A is greater than C. Then B is less than C. Otherwise, A times B would be greater than C squared. A contradiction again. So we can write A as C plus M and B as C minus N for positive integers M and N. Then c squared is equal to ab plus c. A is c plus m, b equals c minus n. Combine the terms, we got c squared plus m minus n times c minus mn plus c. Both sides contain c squared. Cancel that out. We got mn equals c times m minus n plus 1. Both mn and c are positive integers. Therefore, c is a positive factor of m and n. Of course, mn is greater than or equal to c. The rest is straightforward. A minus b squared, c plus m minus c minus n squared. That is actually m plus n squared, which is further equal to m minus n squared plus 4mn. M minus n squared is greater than or equal to 0. 4mn is greater than or equal to 4c. The proof is done. Thank you for watching.